7 quadrilaterals. Because of our crazy thing, our very first snow day, this is what we're working on today. So a little bit of few changes. Guys, quiet please. Few changes to note here. So this will change a little bit over the next couple of days. But we are looking at section 7.3. And once we're finished with notes, then I'll release the Delta Math assignment for you. So here we have the notes. 7.3, parallelogram proofs. All right, so today we're going to be proving that a quadrilateral is a parallelogram. How do we know something is a parallelogram? Do you need to get it from your locker? That's a quadrilateral. A quadrilateral has 4 sides. How do we know? Parallel. Okay. So we have 2 sets of parallel sides. Okay. So how do we know, like, what proves parallel? How do we know things are parallel? They have the same slope. Yes, very good. They have the same slopes, okay? And so we're going to be looking at the same slopes. So we should have 2 sets of same slopes. And then the other thing that parallelograms have is they have opposite sides are congruent. So 2 sets of congruent sides. And we can do that, find those side lengths using the Pythagorean theorem. Everything that we're doing today we have done 1,000 times already, okay? And so once we get this single thing done, then your assignment, you should be able to finish before the end of class, no problem. So to get started, we're going to go ahead and plot these points. So C is at -3, 8, -3, 8, and I'm going to label it with a C. Make sure you label those points. 1, 5 is D. And we have 9, 3 is E. And 5, 6 is F. Put on the answer there. Which is a very weird looking shape, but I'm going to go ahead and connect C and D together and E and F together. And then I can go ahead and connect the bottom and the top. All right, so this is a very sort of smushed, shall we say, parallelogram. And I just want to point out these diagonals. This diagonal DF, is it the same length as the diagonal CE? Absolutely not. The diagonals are not the same length, okay? Very different here. Cool. Oh, go to the window and grab one. All right, so I am going to use different colors, and you can see once we graph this, Delta Math tells you exactly what you need to do here. So we need to find the slope of these lines, and then the length of the sides. And to do the length is very easy. It's just the square root of a squared plus b squared. And so we're going to be using our little picture to help us out with that. So the first thing I need to do is find the slope of segment CD. So I'm going to start here with segment CD. And I'm going to go ahead and draw my vertical and horizontal little triangle legs, because that is definitely the easiest way to do this. What is the vertical length here? 3. And what's the horizontal length? 4. Very good. And so what we need to look at first is this segment CD. Is this a positively sloped segment or a negatively sloped? It's negative. It's going downhill from left to right. So I know it has a negative. And remember that slope is rise over run. And so of these numbers, the 3 and the 4, which is the rise? The 3 is the rise. That's the vertical piece. And what's the run? 4. All right. So for slope, we know it's rise over run. In our case, it's going downhill. The rise is 3 and the run is 4. So negative 3 over 4. To find the length of segment CD, all I need to do is the square root of leg squared plus leg squared. So we are just going to do the square root of 3 squared plus 4 squared. What is 3 squared? 9. And what is 4 squared? 16. And what is 9 plus 16? 25. Hey, and what is the square root of 25? 5. Okay. Either of these answers are okay. We can leave it as radical 25. It's a perfect answer. It's not simplified, but it's totally fine. Or 5. But I do want to remind you that you are not going to have decimals. If you have a decimal answer, it is wrong. So do not use it. You need to use a radical. Leave it as a radical. Okay? All right, let's look at another one here. Next, I'm going to look at DE, segment DE. So on D and E here, I want my vertical bit and my horizontal bit. So get the legs of my little triangle. What's the vertical length here? 2. And what's the horizontal length? 8. Very good. Is it a positive or negative slope? Negative. We're going downhill. What's the rise? 2. And the run? 8. So negative 2 over 8. You can reduce it to negative 1/4, but you don't need to. All right. The nice thing about not reducing is I get to use the same numbers on my square root here to find the length. You cannot use the reduced numbers to find the length. So we're going to do leg squared plus leg squared. So 2 squared plus 8 squared. What is 2 squared? 4. What is 8 squared? 64. And so 4 plus 64, square root of 68 is that length. And that is a totally wonderful length. All right. Next they tell us go to EF. So EF, again, I want a vertical piece and a horizontal piece. What's the vertical length? 3. And the horizontal? 4. Is this a positive or negative slope line? Negative. It's going downhill from left to right. So it has a negative. What's the rise? 3. And the run? 4. So negative 3 over 4. Hey, look at that. What do you notice about that negative 3/4? It's the same as above, yeah. And if they have the same slopes, what does that mean? Yeah, they have parallel lines there. Very good. So just as a good reminder there, parallel lines have the same slopes. And then if I want to figure out the length, it's going to be 3 squared plus 4 squared. Wait a minute. I've seen that before. What's that going to be? 5. Yeah, we already did that. I don't need to do it again. All right. Questions so far? Isn't it pretty? Look how colorful it is. Oh, hey. What do you notice about these lengths? They're the same length. Look at that. GTH. Okay. Fantastic. Okay, one more FC. We've got a vertical piece, and we have a horizontal piece. And what is that vertical length? 2. What is the horizontal length? 8. Is this a positive or negative slope line? Negative. All right, that means it's negative. The rise was 2. The run was 8. Oh, hey, look at that. What do you notice? Same. We have, again, another set of parallel lines because they have the same slope. And once again, if I find my length here, 2 squared plus 8 squared. Wait a minute, I've done that before. It is radical 68. And once again, there's another set that are the same length. So we have 2 sets of parallel lines and 2 sets that are congruent in length. Opposite sides are congruent. So this quadrilateral can best be described as a parallelogram. They're all parallelograms today, ladies and gentlemen, because it's all we've talked about. Okay. Now, on your Delta Math today, I have, on the back side of this, I've given you a few graphs. So if you want to write them down, you can graph them on screen and then do the graphs on paper just so you can draw the triangles so you don't have to squint and count. Okay, it might be helpful. It's totally your call. But I will release that Delta Math. And you'll absolutely be able to finish today.